The artificial intelligence revolution is redefining not only the global technological landscape, but also fundamentally transforming worldwide energy demand. Behind every Google search or ChatGPT interaction lies a complex infrastructure that consumes massive amounts of energy, revealing a surprising reality. Data centers already represent 1.5% of global electricity consumption, and a single data center can consume as much electricity as 2 million households. In this context, natural gas emerges as a crucial player, not only maintaining its position as the world's second most important electricity source, but also expanding its global reach through liquefied natural gas, LNG, which facilitates energy transportation and storage to fuel this digital revolution. Carlos Bastida, business intelligence consultant, has prepared a comprehensive summary on these topics and their practical implications in today's world. Don't forget to subscribe, like, and activate the notification bell, as well as visit his website to learn more about his services. Let's begin. Artificial intelligence, AI, is transforming the technological and energy landscape, driving growing demand for data centers. These centers, essential for training and operating AI models, consumed approximately 415 terawatt-hours in 2024, representing 1.5% of global electricity consumption. The United States leads with 45% of the total, followed by China at 25% and Europe at 15%. Since 2017, data center electricity consumption has grown 4 times faster than total electricity consumption growth. AI-focused data centers are particularly intensive, consuming as much electricity as aluminum smelting facilities. The AI boom has enormous implications for energy. Training and using AI models takes place in large data centers, and global investment in these facilities has doubled since 2022. A large data center can consume as much electricity as 100,000 households. The largest, currently under construction, could consume the equivalent of 2 million households. Investment in data centers has experienced a boom, doubling since 2022. In 2024, it reached $500 billion. Building a single AI data center can cost between $40 and $50 billion, according to BlackRock, reflecting the magnitude of the financial effort. This investment boom has generated concerns about the exponential increase in electrical demand. Data center electricity consumption is projected to double, reaching 945 terawatt-hours by 2030, with the United States and China being the main consumers. In the U.S., data centers could exceed the combined electricity consumption of industries like aluminum, steel, and cement by the end of the decade. Consumption projections vary according to different scenarios, depending on AI adoption and efficiency improvements. The CEO of NVIDIA has mentioned that building artificial intelligence infrastructure requires massive investment, billions of dollars, and they currently only have a fraction of that amount, $150 billion. To close this financial gap, NVIDIA has partnered with BlackRock and other major technology companies. This combined capital will be what actually finances AI development in the U.S. To satisfy this demand between 2030 and 2035, renewable energy will lead with an increase of 450 terawatt-hours, thanks to its economic competitiveness and technology companies' acquisition strategies. Natural gas will contribute an additional 175 terawatt-hours, mainly in the U.S., while nuclear energy will also contribute, especially in China, Japan, and the U.S., with the first small modular reactors expected by 2030. However, electrical grid constraints pose risks. 20% of planned projects could be delayed due to connection problems, long transmission line timelines, and high equipment demand. Now let's continue with the next topic and learn some data about electricity generation, investments, and trends in this industry. Coal remained the world's primary electricity generation source, a position it has maintained for over 50 years. In 2024, it represented 35% of total energy generation. Natural gas was the second most important electricity source, providing more than 20% of global electricity for over 2 decades. However, the global energy matrix is evolving. Energy generation is diversifying. Let's look at the table showing the main sources of electrical energy generation in 2024. Energy trends show rapid growth in renewable energy, driven by policies, technological advances, and market demands. Natural gas maintains its relevance with the expansion of liquefied natural gas, while nuclear energy remains stable or grows in some countries, with innovations like small modular reactors on the horizon for 2030. Overall, the global energy system adapts to balance growing demand, such as that from data centers, with sustainable supply. Let's learn some data about natural gas extraction and consumption worldwide. Natural gas, a mixture of gaseous hydrocarbons found naturally in underground deposits, composed mainly of methane, used as fuel and industrial raw material. Its unit of measurement is BCM, meaning billions of cubic meters, which is a standard unit of measurement used in the natural gas industry to express production, consumption, reserves, and international trade volumes. The following table is a summary of global natural gas consumption and extraction, broken down by regions and with emphasis on key countries such as China, Russia, and the US for the years 2021 to 2025. The left columns show annual volumes consumed and the right columns show annual volumes extracted, including regional and global totals. Natural gas plays a key role in industries. Let's talk about natural gas in a different physical state. Liquefied natural gas, LNG. Natural gas that has been cooled to approximately -162 degrees Celsius to convert it into liquid, reducing its volume by 600 times to facilitate transportation and storage. This process is called liquefaction. Its unit of measurement is BCM, meaning billions of cubic meters, which is a standard unit of measurement used in the natural gas industry. Global liquefaction capacity is currently 670 billion cubic meters, BCM, per year and is expected to increase by 290 BCM annually between 2025 and 2030, thanks to projects under construction. The following table shows just some of the liquefaction plant projects under construction. This landscape, where technology and geopolitics intertwine, is not just a challenge but an immense opportunity for companies willing to innovate. Just as AI transforms data into instant decisions, your business needs the capability to convert current market complexity into competitive advantage. For Latin America, in particular, strategic adoption of these technologies is not just an option but a path to relevance in the new global economic order. The global energy chessboard is being reconfigured with massive investments of up to $50 billion per data center, where giants like BlackRock and NVIDIA redefine digital infrastructure financing. Visionary companies not only adopt these energy innovations, but convert them into competitive advantages to navigate a constantly evolving market. If you're looking to enhance your business competitiveness, optimize your resources, and capitalize on the vast opportunities that the AI era presents, enabling you to make informed decisions in this changing environment, I invite you to explore Carlos Bastida's website to learn about his service portfolio and discover how business intelligence can be the compass you need. Let's start building your company's future together.